Hit sign in here, huh?
Yeah, I got out, so you should be good.
Okay. Do you know whether it will not let two people be in at the same time?
You know, I've never tried that, to be honest, because no one's ever wanted to get in at the same time.
It didn't like my sign in.
Sometimes it does that. You just have to retype it.
Yeah, what? Oh,
Capital
D
capital,
given? No, what is the password again?
capital D.
Apple D?
No, D, capital D, though. You know, like right, D-A-Z-Z-A.
Hold on. I tell you what, can you type it into the chat window and I can just copy and paste it like I did before. Unfortunately, my hearing is such that distinguishing between D's, B's, C's, and E's is really hard for me. There we go. Now I can just copy and paste it. Huh. Didn't like memorizing it. All right, that worked. Direct me from here. I don't...
Okay, so go to the number 4, college algebra, on the left. Courses, under courses.
Okay. Does this university have a physical location also?
Yeah, it's in Salt Lake City.
Oh, okay. And...
Go to launch course.
Okay.
Okay, so let's go to hit lessons.
Okay.
Then go hit all. Underneath lessons, hit all.
Okay. Go back to 2, chapter 2,
yeah.
where we left off. Okay.
Yeah.
And
I think we did 2.2, right?
yeah, we were working on it. I'm not sure if we finished it or not, but let's try 2.3 here. And we want practice, right?
Yeah.
Okay, graph following equation by plotting 2 points. Well, these kind of questions are actually pretty easy because you can make up a value for x and figure out what y is, and then you can make up another value for x and figure out what y is. And that's probably the easiest thing to do. In other words, make up a number for x that's going to make this calculation very easy.
I'd say maybe 2.
Yeah, or 0 even.
Yeah.
The easiest one usually is 0 because it's really easy to do the calculation then. And so now what do we have? Y minus 1 equals what?
8 minus 1.
Well, first of all, multiply minus 8 times minus 4. In other words, substitute 0 for x.
So it would be 32, minus 32.
Actually, plus 32.
Oh, plus 32, sorry.
Because it's minus 8 times minus 4.
Mm-hmm.
Which makes y 33. Okay? So, one point that I know for sure is on this graph is 0, 33. Well, let's find another point. Let's make x equal to 4. That's a pretty good value to assume, because look what happens. If x is equal to 4, it makes the entire right side of that equation equal 0. So now I have y minus 1 equals 0, y equals 1. So the other point is 4, comma 1. Now I have 2 points that I can plot. So there really wasn't, I didn't need to really solve this equation for y. I didn't need to put it into any particular format. So all I needed to do is just make up a value for x and figure out what y was. And then make up another value for x and figure out what y is at that second value. Okay. Now I notice a problem here. I cannot plot the point 0, 33 on this graph. So make up another point other than, in other words, they only made the y-coordinate go up to 10. So I need to figure out another value for x that will allow me to have a y value that's less than 10. Well, how about 3? And now I get y minus 1 equals minus 8 times 3 minus 4. So I get y minus 1 equals positive 8, which makes y equal 9. In other words, when I use an x value of 3, I get a y value that I can actually plot on the graph they gave me. So the first point I'm going to plot is 3, 9, right there. And the second point that I'm going to plot is 4, 1, right there. So it was a little tricky. In other words, when I picked my favorite number, which is 0 for x, it gave me too big of a value for y. It didn't fit on the graph that they gave me. So I had to rethink that point. And 4 worked really well. It gave me a y value of 1. But so I figured, well, I'll try 3. I can see 3 is going to certainly give me a y value that is less than 10. And that's all I needed. All right. Little different question. Find the equation in slope-intercept form. Let's talk about the various forms for straight lines. Okay. Slope-intercept is the most common one. Slope-intercept form is y equal mx plus b. We talked about this a little bit the other day.
Yep.
There's also point slope, which I don't know if they've taught that to you, but it's similar looking. And notice that one way to memorize the point slope is if I happen to divide both sides by x minus x sub 1, I get m equals rise over run. So one way to help memorize point slope format is this. Okay? These are actually the two primary formats that we're always going to be dealing with, is slope-intercept and point slope. Now, they have requested it to be in slope-intercept, which means that I need to solve for m and b. and I need to give them an equation. Y is equal to some number times x plus some number. Okay, so let me draw a line through that so we're not confused. So they gave us the slope, so I can write most of it right off the get-go. In other words, I can write that much of it just from the fact they gave me the slope was minus 4/3.
Yep.
But I still have to solve for b. But they also gave me a point that the line goes through. It goes through the point 0, minus 9. So if I substitute those two values for x and y, I'm going to be able to solve for b.
Mm-hmm.
In other words, y would be minus 9. Remember that any point that a line goes through has to satisfy the equation. So that's all I did was plug in that point for the x and y coordinate. Now anything times 0 is 0, so that goes away, and I get b equals minus 9. Now I have my full equation. Y equals minus 4/3 x minus 9. There's my answer. Now, putting it in there, do I have to hit keypad or what do I have to do?
Yeah, you can type the y equals, then negative, and then the keypad.
Okay. And 4/3, right?
Mm-hmm.
Changed my keypad since our last session. My wireless gave out on me yesterday and I had to go get a hardwired keypad. And now I can just type minus 9, is that right?
You're going to put the x in.
Ah, okay. How do I, okay, I got you. Minus 9. Okay. Same problem. So, let's have you do it this time. There's the format that they want us to put it in.
Mm-hmm.
Okay, how much of that do I know based on what they've told me?
Well, we know that y is 4/5.
Well, yeah, but let's plug in what we know immediately. We know slope. They're giving it to us. So let's plug that in for m.
So y equals negative 8/5.
In other words, when you know slope, you can write most of the equation.
Mm-hmm.
We still have to solve for b. And the way you always solve for b is, what am I going to do again?
What do you mean?
Well, that's what you wanted to do as your first step, was plug in 4/5 for y and 0.
So y would be 4/5
Okay.
equals negative 8/5 x.
Not x, 0.
0 plus b.
This point that the line goes through has an x-coordinate of 0 and a y-coordinate of 4/5. Therefore, I can plug it into my equation, and that allows me to solve for b. So b equals 4/5, and now what's my equation?
Y equals minus 8/5 x minus 4/5.
plus 4/5. In this case, it's plus. In the last case, we got a negative b. But in this case, b is positive 4/5. All right, here, I got to get my keypad closer to me. So let's see, I got to go straight to the keypad. I guess I can hit a negative sign. Oh, I got to hit y equals also. Y equals negative keypad 8 divided by 5. And do I do like right arrow? Yeah. Plus, and then I got to do this again. Boy, they make it kind of cumbersome, don't they? Somebody needs to design their program, improve it a little bit. Oh, I forgot the x.
You have to go try again. Then you should be able to insert the x.
Okay. I've done calculus on these kind of programs where you have to put it in just a certain way. It is one of the most frustrating things in the world. Just because calculus is so hard, and then you got to get the answer in the exact perfect way they want it. All right, so this one they still want it in slope-intercept format, but they tell you the slope in this case is 0. So how much of the equation can I write?
Y equals b.
Yeah. And now the y coordinate is 3. So 3 equals b, which makes the equation what?
Y equals 3.
Okay. And that is the equation of a horizontal line. And horizontal lines are the only lines that have slopes of 0. So the moment we saw that it had a slope of 0, we should know we're going to get an answer, y equals some number. Okay, vertical lines are x equals some number, horizontal lines are y equals some number. I don't have to use the keypad here. Okay, well, let's do at least one more of these, although they're starting to look pretty much all the same. So we can probably do this one and go to the next section, I would think. So, tell me what to do.
So it's y equals 1/2 x plus b.
Okay, now what?
It would be 1 equals 1/2 time multiplied by -4 plus b.
Yeah. And that leaves me with an equation that only has one variable, so I'm always going to be able to solve that. V equals 3. So y equals 1/2 x plus 3. So anytime you have a fraction, you have to do this, huh? Awesome. Oh, okay, I didn't hit next. Yeah, these are all pretty much the same. Are you comfortable with this topic that we can move forward?
Yep.
Okay, so we hit what now?
You go to save and end practice.
How come I don't see the save?
Up on the top left.
Ah, see.
Then save and exit.
I'm going to go back to college algebra.
Yep.
And lessons. No, it's showing me them. So we're still on 2, right? That was 2.3a.
So let's go to 2.4.
Okay. 2.3b is a different format. It's point slope instead of slope-intercept.
Yeah, but it's not assigned, so it's not part of the...
Oh, I get you. Okay,
course.
I got you now. Okay. I was misunderstanding what you were thinking there. Functions and function notation. All right. Definition of a function, there's a layman's definition of it, and it means it has to pass a vertical line test. And what that means is, can I go from left to right with a vertical line and only intersect that function in one spot ever? And the answer is yes, I can. It's hard. You know what I'm trying to describe? In other words,
Yeah, is this the one where you have like, if you have like an S curve or a U?
yeah, exactly. Here, let
If the vertical line passes...
Right, here, I can figure it. I can figure out how to do it now. If I had a function like that,
Yeah.
that passes the vertical line test because no matter where I draw a vertical line, I only get one value of y.
Yeah.
Okay? Whereas if I had this, that's not a function. If I draw a vertical line through that, I get that value of y, that value of y, and that value of y. Notice that a vertical line is not a function. That might be x equal 5, but it's not a function. It does not pass the vertical line test. Whereas if I had a horizontal line, y equal 5, that does. That's a horizontal line. That passes the vertical line test. No matter where I pass a vertical line, I only get one value for y. Okay? So this is definitely a function. How come I don't see the no answer?
Well, you got to scroll down or...
I see the yes answer, but the no, there's no answer. I don't need the no answer. Maybe they're giving us a clue by not putting the no answers in. All right. Determine the domain and range of the graph. Okay. First of all, domain means all of the allowable x's that you might plug into this function. Range means all of the possible y's that might come out of this function. Well, those two arrows that you see means that the function goes on to infinity. In other words, it doesn't stop there, it keeps going. So on the x-axis, what is our domain going to be?
Infinity.
Negative infinity to positive infinity. But you're right, all real numbers. In other words, there's a few ways that I can write that. That means all real numbers. You can also write it in interval notation, which they may want. I got to read a little bit more. In other words, x can be any number you can think of, and there's no restrictions on it. As opposed to, let me write this function. not this problem, but this function, that has a restricted domain. X has got to be greater than or equal to 0. You cannot take square roots of negative numbers. So this would be my domain for the function y equals square root of x. But when you have linear functions, this is linear because it's a straight line. Straight line functions almost always have domains that are unrestricted, in other words, all real numbers, and ranges. In other words, if I look at the possible values for y, you'll see that I can go from negative infinity to positive infinity vertically also. Not just horizontally, but also vertically. So now the question is how we're going to get this in here. Select a, I guess I need to hit keypad, huh?
Yeah. You have that infinity icon.
You have infinity, but the question is how to put it in there. There's the double all reals also. Gosh, I'm not sure what they're looking for. They may be looking for this one. I'm going to put in this. Negative infinity, comma, positive infinity, like that. And that's interval note. Oh, it's also got a button for all reals. I probably should have hit that. I wasn't looking. Let me go ahead and hit that. Now, the question is, do I need to go back and erase what I put in? Let's see if it likes that answer. All real numbers. Your answer seems incomplete. Please try again.
Do you have to put the range in as well?
Maybe.
Scroll down.
Maybe. I don't have a scroll bar anywhere.
You see where it says about submit answer on the right, just above that.
Ah. Yeah, you're right. It wanted range also. So I'll put all real numbers for domain and all real numbers for range. Let's see if it likes that. Yeah. Okay. And like I said, domain and range can be described in multitudes of ways. There's something called interval notation, which is what I tried to put it in as, but I didn't need to. I should have chosen their button that was the easiest one. All right, let's look at another one. All right. How do I find this notation, f of x, means the same as y. In other words, I could write this function two different ways. One, I could use y, like this. And the other, I can use f of x. Now, f of x has some advantages over y. For one thing, it tells you you're dealing with a function that's in x. It's not in r, it's not in t, it's not in theta. It's the variable you're going to find on the right side of the equation is x. And this y notation doesn't tell you that. Okay, so automatically f of x is superior. But another big thing that it allows you to do is to evaluate the function at any number you want. Well, they want us to evaluate it at -6. And what we're going to do is plug in -6 wherever we see x. That's what you do, and whatever is in the parentheses, we're going to plug in whenever we see x. And it can be a complicated expression. It could be something like, what is f of x plus h? Well, then I'm going to plug x plus h in wherever I see x. But in this case, it's straightforward enough. So the way I recommend doing these is not to ever try to do two steps at once. In other words, just plug it in and then we'll simplify it. And always use parentheses. because sometimes they matter. In this case, they really matter, as opposed to not using parentheses. So there's what I get when I plug everything in, and now simplify that. By simplifying it, get rid of the squares, do your exponentials first, and then get rid of all the parentheses. So it's minus 6 squared.
36.
Okay, so that becomes 3 times 36. And what's 6 times minus 6?
0.
Multiplying, it's minus 36.
Minus 36.
Okay, and I've got a plus and a minus. So if I were to write both of them, it would look like this. But whenever you have that plus and minus and you want to get rid of the parentheses, drop the plus. And I still have the 8. Okay, so this is 108. That's what 3 times 36 is. And then I'm subtracting 36 and adding 8. So what is that? 72 plus 8. That's equal to 80. And so this would allow me to evaluate the function at any number I want. I could figure out what f of 10 is. I could figure out what f of 0 is. So it's one advantage of using f notation. And it's not f times x. It's f of x. And it doesn't mean multiplication either. It just means you have a function of x. Find the value of a. Okay. So what is f? In other words, I still have my f of x equals 3x squared plus 6x plus 8. What does f of a equal? Remember, whatever's in the parentheses, plug it in for x. Always.
So 3 multiplied by a squared plus 6 multiplied by a plus 8.
Not, we can't reduce that any. That's what I'm going to put in. Now, 3a, to square it, do I need to use the keypad?
Yeah. Go to the top, the one on the left, top left.
Okay. And I got to use the arrow key, plus 6a, plus 6a, plus 8. Looks like I might have an extra space. Is that going to hurt?
No, you're good.
Okay. I won't worry about backing that out of there then. All right. Now, this is a little more complicated function. This is just looking at this function. What is the only thing that x cannot be?
It cannot be?
Yeah. That's the way you should look at domain, is not so much thinking about what x can be, because usually x can be most anything. But there is one specific thing that x cannot be here. And the number one law of all of mathematics is thou shalt not divide by 0. So what value for x would make us divide by 0?
What do you mean? I don't understand.
Well, okay, here's what I want to do. I'm going to take our denominator and I'm going to make it equal to 0. And that's going to tell me that x can never be 5. because I cannot divide by 0. That means this denominator can be anything I want except 0. So I solve the equation, setting it not equal to 0, which means x cannot be equal to 5. Notice that if x were 5, we'd be dividing 17 by 0.
Okay.
So it's all real numbers except x equal to 5. Now let me see if I can figure out how to put it in. Maybe this way. Did it do anything when I clicked that? Yeah, it said all real. But now the question is, do I need a comma? You know what? Let's try interval notation instead. And interval notation would be negative infinity. Ooh, man. I'm not sure what it's going to want here for notation. Let's try interval notation. So it's negative infinity, comma, 5 with a parentheses because it can't be equal to 5 in combination, which is what that symbol means, with another parentheses, which is going to go from 5 to positive infinity. In other words, look at that answer, and do you see how that covers all real numbers except 5? There's a difference between a parentheses and a bracket. If I would have said minus infinity to 5 with a bracket, that means it could be 5. But if I put a parentheses there, it can be anything up to 5, but not 5. Okay, and then of course, all numbers greater than 5, I got to write like this. So this interval covers everything except 5. Now, I might have also been able to do it kind of like this, except x not equal to 5. But I don't know if I needed a comma or not. Let's see if it likes this. Yeah, so it handles interval notation just fine. And the advantage of interval notation is sometimes you can have lots of intervals. For example, if I had a function y equals 1 over x minus 3 times x minus 7. Well, notice what two values x cannot be. X cannot be 3.
Or 7.
And it also can't be 7. If I want to spell that out in interval notation, I'm going to be negative infinity to 3 in union with 3 to 7 in union with 7 to positive infinity. So interval notation gives you the advantage in being able to put multiple intervals down. And that's why it's kind of the standard format. All right. I guess we're ready to go next here. Okay. What kind of line is this? Is this a curved line or a straight line, this function that they're giving us?
Let's say that.
Notice that it is in y equal mx plus b format. That's a straight line.
Okay.
Whenever the power of x is just 1, it's linear, meaning a straight line. So it doesn't matter. I could have y equal 1/100th x minus 1,000,000. That's a straight line. okay, because x is only the power of 1. If I had y equal x squared, that's not a straight line. That is a parabola.
Mm-hmm.
It looks like that. So all straight lines can be expressed with functions where x is just to the power of 1. And all straight lines have a domain that is all real numbers and a range that is all real numbers. At least I would think the only straight line that might not do that would be a vertical line. Notice that if I had a vertical line, we'll call this x equal 5. Well, my domain is just 5. That's it. X can't be anything other than 5. My range would be negative infinity to positive infinity.
Mm-hmm.
So the only line that is not all real numbers for both domain and range would be a vertical line. And a horizontal line, now that I think about it. In other words, let's put a horizontal line up there at 4. Well, now the domain is all real numbers, but the range is y equals 4 only. If I give any slope to that line at all, even if it's just a really small gradual slope, that's supposed to be a straight line, but it's got some slope to it, well, then the domain is going to be all reals and the range is going to be all reals. I mean, this function doesn't rise very fast, but it eventually will go to positive infinity on the upside, and it'll go to negative infinity on the downside.
Mm-hmm.
So straight lines are always all reals unless they're horizontal or vertical. So let's see what kind of answer they'll let me put in here. Should I just try that big R? All reals, and then, oh, they just want the domain. Let's see if it likes that answer. Yeah. In other words, it didn't require me to say negative infinity to positive infinity. It let me just put in that R, that kind of a double R there,
Mm-hmm.
which is all real numbers. Does this pass the test for a function?
I would say yes.
Yeah, if I pass a vertical line, in other words, if I draw this thing over here, here's the function they gave us. Well, no matter where I pass a vertical line, I only get one exact value of y. I don't ever get two values for y. That's the definition of function. So yes, it does. Determine the domain and the range. Well, what's the domain?
Well, it's an infinity problem again.
Correct. All real numbers. So they give me a shortcut way of doing it here. In other words, when you're looking at domain, you want to be looking horizontally. That's it.
Mm-hmm.
You're not looking vertically. You're just trying to figure out what can x go to if I go all the way to the left, and what can x go to if I go all the way to the right. And you can see that eventually we'll hit negative infinity and positive infinity horizontally.
Mm-hmm.
So my domain is all real numbers. Now range. range look vertically?
It's the same.
Y never goes positive, right? Y is always, the value for Y is always a negative number in this case, right? No matter if I put my cursor there, I got a negative Y. If I put my cursor over here, I got a negative Y. Down there, a negative Y. In other words, Y is less than or equal to 0. It's equal to 0 right there. So it can be 0, but it can never be positive. I don't see any part of the curve above the x-axis, which I would have to have. Okay? So the range, let's see what it will let me put in here. Y has to be less than or equal to 0. Should accept that. But you can always figure out domain and range by looking at the graph. You don't have to do any math at all. It's just a question of, for domain, looking at the graph horizontally, and for range, looking at the graph vertically.
Okay.
Okay. So here's my function. F of x equals 2x plus 8, and they want to know what f of minus 1 is. What do I do?
So 2 multiplied by negative 1 plus 8.
Which is minus 2 plus 8, which is 6. Okay, now they're getting a little bit more complicated. Hold on a second. Let me erase some of this stuff. Same function, but this time they want to know what f of a plus 5 is.
So 2 multiply a plus 5 plus 8.
And now simplify that. They're not going to like that answer because I can reduce it. I can simplify it. Distribute the 2.
So a plus
Well, 2 times a is 2a,
yeah,
plus 2 times 5 is 10.
plus 8.
There I've distributed the 2, and I still have my plus 8. So now when I simplify, I've got 2a plus 18. That's going to be the answer they're looking for. 2a plus 18. You pretty much always have to simplify something if it can be simplified. If you submit it in unsimplified form, I can't imagine they would ever accept it. Is this a function?
No.
No, it isn't. It does not pass the vertical line test. The scroll bar is what disappears on me here every now and then. I can barely get to the no there. But then, oh, I know what's happened. So, yeah, okay. Sorry. This new version of Windows I have has these pop-ups that show up on my lower right side all the time.
Huh.
I haven't yet figured out how to get rid of. Every other day I've had drama with my computer, between having my hard drive crash 2 weeks ago to having my wireless keyboard going out twice in the last week. There's nothing worse than having your computer or your phone stop functioning.
Especially with what you do. Especially with what you do.
Yeah, for sure. I know. I mean, I had a bunch of appointments, and I woke up in the morning and couldn't even log into my computer because it wouldn't accept anything from my keyboard. All right, determine the domain and range of this. What's the domain of this function? Look strictly horizontally. What can x be? Now, in this case, it's okay to say what can x be because saying what x can't be is a lot more information. So what can x be?
Well, it's on the negative side, right?
It can only be -8, right? In other words, no matter where I'm at on this function, if I'm there, x is -8. If I'm down here, x is -8. If I'm down here, it's -8. If I'm anywhere up here, it's -8. So -8 is the only thing that x can be on this. The range is what?
That's
now
also...
Now look vertically. In other words,
yeah,
look up and down.
It's infinity.
All real numbers.
Yeah.
In other words, it's -infinity to +infinity. Saying just infinity doesn't quite spell it out enough. Because all real numbers mean any number that goes from -infinity to +infinity. So the domain was x equal -8. And the range is all real numbers. I love their words of encouragement. Must be like writing fortune cookies. Somebody's probably sitting in an office somewhere coming up with 1,000 different ways to pat you on the back. Does this graph represent a function?
Yes.
Yeah, it does. In other words, it passes the vertical line test. These closed dots here, what they mean is if it's a closed dot, then x is allowed to be -2. And x is also allowed to be 4. So let's just look at this before I answer and go on. If I was doing the domain for this, well, I would use brackets. X can go from -2 to 4, and the brackets means that it can be any number between -2 and 4, as you can see from the curve, but it can also be -2, and it can also be 4. If these were open circles, in other words, if the graph looked like this, an open circle means it can't be those numbers. And that would look like this, -2 to 4 using parentheses. So that's the difference between parentheses and brackets.
So the parentheses means that it cannot be -2 or 4.
Correct. It would have to be between -2 and 4, but it couldn't be those specific numbers. And that would also show up, it wouldn't be a closed dot, it would be an open dot. Okay? In this case, the question is yes, and then I'll bet you they're going to ask us the domain next. Yeah, determine the domain and range. So what's the domain?
So it's what we identified, right?
Yeah, let's put it in interval notation. In other words, I'm going to use the keypad, and you see this one that's got bracket on both sides? That's what I'm going to use.
So -2 to 4, right?
-2, 4. Yeah, you need the comma also. Okay, so there's my domain. About range, what can range be?
It can be, what is that, -6 to -3?
Yeah,
Or
negative
the other way around?
6, exactly. And when you're doing range, you always go bottom up. In other words, I would never say -3 to -6. That would be going from the top down.
Okay.
Okay, do I need parentheses or brackets? Or a combination of them?
I think you would need brackets, right?
On both sides, yeah. Because y can be -6, because that closed dot. And if I put my cursor right there, you can see that y can also be -3. When x is 1, y is -3. So I need brackets again. So I'm going to use this same bracket sign. Whoops. What did I do? Oh, I got to scroll down. -6 to -3. Alright, so I'm going to first put it in there, put the brackets, -6, comma, -3. And there's brackets on both sides of that, and I've got the domain with brackets. That should be it. Notice that a circle is not a function. That what we were just looking at was half a circle.
Yeah.
It is a function. But if I were to draw an entire circle, I could not be able to pass a vertical line through it without finding two values of y.
Mm-hmm.
Does this represent a function?
Yes.
What is its domain? Look, think horizontally.
These are all real numbers.
Correct? All parabolas' domain is always all real numbers.
Mm-hmm.
Not only straight lines that have any slope at all, but parabolas. This is a parabola, and you end up with a parabola when you have squared. In other words, if I have y equal x squared, that's always a parabola. Now, sometimes it's a parabola that opens up, sometimes it's a parabola that opens down.
Mm-hmm.
But in either case, the domain is all reals. In other words, there is no restriction to what I can let x be. And you can tell that from the function that I've written. You can see that I'd be able to put in whatever value I wanted for x. The range is not all reals. What's my range in the function that we're looking at, not the one I wrote? Think vertically.
Well, it would be -4 to is that? But that's also real numbers, right?
Those arrows mean it goes all the way to positive infinity.
Yeah.
So that's its right hand. And infinities never have brackets, always parentheses. And the reason is that infinity is not a number. It's more of a concept. It is growth without bound, which means it can't be a number, which means I can't really put a bracket around it. So whenever you have either a negative infinity or a positive infinity, you get parentheses. It can be -4. I'm looking at right there. If x were 3, y would be -4. So, okay, we have our answers. Let me put them in. So the domain was all reals, and the range I need to pull up the keypad and use this one. Bracket on the left, because it can be -4, comma, infinity on the right with a parentheses. All right. Is that a good place to stop, Darren?
Yeah, that's good.
Okay. You're keeping track of these, so you'll know where to start next time?
Yeah, we're actually through this chapter, so I'm going to take...
Feel free to go forth without me. In other words, I don't think there'd be a problem if at our next session we were in chapter 4, if you've already finished chapter 2 and gone on to 3.
I mean, it's good for me to review this stuff with you, though.
Okay, so even if you have gone through it, it's worth going through every piece. Okay, that's fine. And let's see, for me to save and end practice, I do that and that. And now I got to sign out by going to your name and logging on sign out. Okay, so I'm out of your program. You can get back in whenever you need to. Let me close it out there.
And then just close out, log me out under my name, top right.
Oh, I got to log out. I thought I did already. I guess I didn't log out the first time. Oh, okay. Yeah, whenever you log out, it takes you back to this screen, I guess. Huh?
Yeah.
Okay.
All right. Well, I made a payment for this last lesson.
I saw that. And let's see, you also scheduled another one. Let's just verify. Wednesday at 3.
Yeah, I'm on spring break this week with the kids, so I'll be here.
I was going to say, you must not be a golfer if you're scheduling a 3 o'clock session. Are you a golfer?
I'm playing golf on Tuesday, so.
Oh, you play golf on Tuesdays?
Yeah.
Are you a good golfer?
Well, not bad.
Were you a golfer before you joined Bear Creek?
Yeah, I grew up playing golf when I was a kid in England.
Yeah, I've been a lifelong golfer. I've not played Bear Creek, but I've played Fox Hollow hundreds of times.
So I'll tell you what, David, you get me through this exam, I'll take you out to Bear Creek and I'll pay for you around.
You got a deal. You got a deal, Darren. We'll definitely do that.
All right, sounds like a good plan.
Okay.
I'll talk to you next week.
What's that?
I said I'll talk to you next week.
Okay, sounds good. Talk to you. Bye-bye.